Now, next topic here is polyatomic ions, and the root here is the word poly, meaning many, atomic, meaning atom, so it means literally many atom ions, like that. So that's basically what a polyatomic ion is it is not just one particular atom, like chlorine becoming chloride. It would be several atoms that are stuck together that travel around together but have a charge when they do so. And so you have a sheet that is a list of common polyatomic ions, and so get that out if you don't mind. As well as you probably also want to get out your nomenclature guide, and so that one right there is going to tell you a little bit about some of the stuff we've already talked about, but we'll also talk about some of these polyatomic ions. The list of sheets that you have for your polyatomic ion sheet gives you a list of different polyatomic ions, what their charges are, what their formulas are, and what their names are. Now, in terms of the way the names work, we're going to talk a little bit about that, is that there are two types of polyatomic ions we're going to run into. One type is going to be basically the oxygen stabilized polyatomic ions. We'll talk about that in just a second. The other type are sort of the odd types, the type that there's no real rhyme or reason that we're going to cover as far as why they're named what they are. Those would be things like hydroxide or cyanide that look like, based on their ending, that they'd be a monatomic ion because it has "ide" on the end, but they're actually not. You just have to remember that that's what they are. Or actually, well, it's on the sheet. You have to use the sheet to figure out what they are. So that's what you've got for your basic naming conventions there. These are covered on the back of your nomenclature guide. If you take a look at number 15 on the back there in part 2, it says if the anion portion of the compound is polyatomic, go to 19. And then it says, then it takes you to 19. It talks more about these oxygen stabilized. It says most polyatomic ions are composed of an element combined with some oxygen atoms. So let's take a look at that case. See, we've got the general form of oxygen stabilized polyatomic ions is that they will have an ending that is 8. Like, for example, carbonate or nitrate or things along those lines. And so those would be examples of a standard general form oxygen stabilized polyatomic ion. And so if we were to sort of use this example, we would say, let's see, nitrate. So nitrate would be one that we have right there. That would be the general form. Now, this is what it talks about, says on number 19. So it says the name of the ion is the stem of the non-oxygen element with an ending that describes the number of oxygen atoms present. Nitrate, as you look on your polyatomic ion sheet, is just something that has, well, I mean, it's NO3, right? And so based on this, what does this say? We have a nitrogen right here, which is why it has the niter on the front. It has 8, which indicates it is oxygen stabilized. So nitrate, the root there means that it's nitrogen, and the 8 means it's got some oxygens attached to it. So that's 19. So, and then it actually tells you to go to 21, which talks about this, that the most common, most stable is added by adding 8 to the stem of the non-oxygen molecule, like sulfate for SO4. And so sulf tells you it's sulfur, the 8 tells you it's oxygen stabilized polyatomic ion. So we got nitrate here. Now, if it has one more oxygen in the general form, that is going to be what's going to happen if you have 22. Say that it says NO3 is what it has on your polyatomic ion sheet, but you're given something that says it's NO4. That's not nitrate, but it's related. And so if it has one more oxygen in the general form, this is what happens on 22. It says it's given a prefix of per, short for hyper, before the name. And so in this case right here is that what you'd have if you had one more oxygen, it wouldn't be nitrate, it would be pernitrate. You take the old one, nitrate, you add per to the front, and that tells you it's going to have one more oxygen. So pernitrate would in this case be just NO4. Now technically these should have charges on them. We won't worry about it right now, but that's basically what we've got there. So pernitrate would be NO4. Now on the other hand, if it had one fewer oxygen, that would be going to number 23 on your nomenclature guide. If it says one less oxygen in the 8 form, the ending is changed from 8 to ite. And so instead of nitrate, this becomes nitrite. And nitrite would just be, instead of NO3, it would just be NO2. It's lost one from the 8 form. And so one fewer oxygen in the form is nitrite. Now, similarly, if it loses 2 oxygens from the general form, that's number 24 on your nomenclature guide. It says if it contains 2 less oxygens than the 8 form, or 1 less than the ite form we just talked about, it gains a prefix of hypo in front of the previous one. So this would be hyponitrite. The ite indicates that it's losing stuff. The hypo indicates it's losing more than just one. And so this would just have a charge of NO, or just have a formula of just NO. And so that's going to be what you have when you have 2 fewer. So the general form that's on your polyatomic ion sheet always end in 8. If it has 1 more oxygen, it becomes pernitrate. If it has 1 fewer oxygen, it just becomes nitrite. If it has 2 fewer oxygens, it becomes hyponitrite. The same rules apply with all the other oxygen-stabilized polyatomic ions. Carbonate is the general form. 1 more oxygen in carbonate would be percarbonate. 1 fewer oxygen would be carbonite. Han Solo accepted. 2 fewer oxygens would be hypocarbonite. And so that's how that would work.